Good afternoon. Thank you for that wonderful introduction. So as mentioned, my name is Rachel Skudder. I'm a project development manager for RWE, based in the Netherlands, but we have, in the generation business, we have also assets in Germany and the UK. What we do in the strategic development department is we're looking at how to decarbonize our thermal fleet where possible. So for the gas plants, that's looking at potentially hydrogen combustion. But what I want to talk about today, and one of my main roles, is our BECCUS projects in the Netherlands. So we have two sites, two remaining coal and biomass co-fired power stations, and we're looking to convert them to 100% biomass with CCS. So we call it BECCUS or BECCS, depending on whether we consider the utilization aspect as well. I'm also a subsurface person at heart, so very happy to be back in a room full of subsurface people. I started my career in oil and gas as a production geologist, doing subsurface modeling and assisting with well design for mature gas fields. So where I am now, I try and be that link between the subsurface people and translating that for my colleagues who are power station engineers. So really interesting to be here today. Maybe just have a bit of a background as to sort of what and the why of BECCUS, and then a bit of an overview of our sites, and then of course can take questions at the end. So yeah, easy question. What is BECCUS? It's bioenergy carbon capture storage. We're looking at converting our power stations to 100% biomass and building a carbon capture plant and then subsequent CO2 transport and storage, which is the focus of what I do specifically. The biomass is essentially predominantly pelletized sawdust, so it's more or less a waste product. And in the Netherlands, there are quite some strict criteria about what is actually able to be burnt and what is characterized as sustainable. So this is one of the value chains that we look at that we have to scale up as we increase the biomass that we burn. And then one of the key points for BECCUS is that it's green electricity production with negative emissions. And that's one of our main value propositions is the negative emissions that we can generate carbon credits that we can then use to sell to customers from hard to abate industries. So for example, you may have heard of the deal between Microsoft and Ørsted. So it's something like 2.7 million tons of CDRs was part of the deal for the next 10 plus years. So that's a similar kind of thing that we're looking at doing, and it's really encouraging to see specifically in the last couple of years that the momentum behind those kinds of business deals and has been ramping up. So I already alluded a little bit to the why, but again, it's value. One of the main value propositions is through the negative emissions, but that's not just for ourselves as part of industry, but one of the points that we like to highlight is that it can help fill the gap between existing emissions targets. So specifically here with the gap in the Dutch emissions targets that I'll show in the next slide in a bit more detail, we can deliver with the two sites between 11 to 14 million tons per year in negative emissions. Really, obviously, one of the key things for that is developing safe and efficient and reliable transport and storage value chains. And for us, it's very much looking at external parties and developing the right partnerships to make that happen. It's also in line with our growing green strategy to be net zero by 2040. So even with the build out of renewables, so onshore, offshore wind, solar PV, we still need to in some way decarbonize the thermal fleet where we can. It also we can also increase our independence by diversifying the energy system that we have. So again, We have a variety of renewable energy available, but you still need that firm, flexible power generation to make up gaps between supply and demand when that happens. So on a daily or seasonal basis, whatever it might be. And not to forget about the U, although it's not a focus of at the moment, is that it is a potential stepping stone to e-fuels and e-chemicals. So at the moment, we see the market for it is not quite mature enough. And in 10, 15 years, when maybe it's a bit more mature, with the volume we have, we still expect that the majority, we would need the majority to be transported and stored. So I alluded to this graph earlier, but just to show in more of a graphical sense what the value could be in terms of the climate targets. So this is in the case of the Netherlands specifically. So the last year, the government announced that they would increase their target from 55 to 60% reduction based on 1990 levels. However, there's still a gap between the middle bar where where the Netherlands will likely get to, and then the 60% target of about 22 million tonnes per year. So obviously these two projects won't do it alone, but it's a significant way to closing that gap. So I mentioned a little bit about value chains already, but just to show this, the BECCS is part of the overall energy system. So it's not silver bullet, but it is one thing that can go partway to achieving those climate goals. So in the case of BECCS, we focus on the red boxes. But on the left, you can see that we also look to the sustainable biomass side of things and scaling up that value chain so that we can combust it in the power plant, take the flue gases, put it through a carbon capture plant, and then onto the CO2 transport and storage. Specifically about the transport and storage side, for us, what's really important is to understand what options we have available. And I think in the last couple of years, we've gone quite a way to doing so. And what's really emerged is the need for collaboration across the entire value chain with on topics like permitting, which has been mentioned, specification, decisions around what kind of conditioning you might have. So how much buffer storage should you have depending on the ship size, number of ships, all that kind of thing. And that really requires quite some open discussion and understanding of the different risk profiles of each option and where the best place to mitigate those risks might be, because it's not necessarily that your risk is best mitigated on your side of the fence, so to speak. So that's one aspect. Okay, so to what I really wanted to show today. This is the first of two sites. So the Armencentrale, it's southeast of Rotterdam along one of the main shipping channels that leads to the port. It's a 600 megawatt power station. It's been producing since 1993 and is currently 85% biomass and 15% coal. And is well on its way to being 100% by the end of this year or possibly early next year. Okay. Can you still hear that? Okay. So by late this year or early next year, and then the goal for this, and also for the other side, is to be 100% carbon capture with transport and storage by the end of 2029. On the right image here is a example of what the plant would look like. So just to match up the center image with the right, so this column here is this one here. So this is the power station, and then to the right of it you can see the carbon capture plant. And for transport and storage, it's basically all about getting the CO2 to Rotterdam, and then from there your options open up as it is slightly inland. So we're looking at both a CO2 barging option to the terminal in Rotterdam for subsequent injection into infrastructure there, or to connect to the Delta Rhine corridor, which some of you may know about. So it passes just a few kilometers south of Armor, and it's a CO2 line that would take the CO2 to Rotterdam. And then to our second site in Eemshaven, so right in the north of the Netherlands, pretty much as far north as you can go. It's much, much bigger and much, much newer. So it's almost a 1600 megawatt power plant with 2 units, which you can see quite clearly in the middle image there. It's only been in operation or commissioned in 2015, so it's only just 9 years old, or not even 9 years old. And it's, in terms of the fuel composition, it's basically the reverse. So it's 15% biomass and 85% coal. So there's much more work there to be done, basically, to convert it to 100%, but that is already well and truly underway. So, for example, looking at this is where the scaling up of the biomass chain is really important, as well as conversion of the coal mills, etc., and quite a number of other work associated with the facilities on the plant itself. Then, of course, we're looking at the carbon capture plant here. So in the top image, both images, you're looking at basically a 2 and 2 formation, so of carbon capture trains, so a total of 4. And then on the left, you see an example of what any intermediate storage could look like. But what's really important here is, especially with topics like specification and for CO2 shipping, the shipping logistics is basically both of those things are defined more or less by the CO2 transport and storage chain that you select. But we are already needing to make decisions on the pre-feed design as we head towards feed of the carbon capture plant. So it's very much key to the discussion that we have with potential partners is what decisions do you need to make that could affect the facilities that we design now, and vice versa. Also, this is a nice picture, but there's a lot of competition for space in the area. So we have other projects there. And so it's not that, maybe you have 7 tanks and let's add another 3. And then that means we have a bit more of a robust shipping chain. There's really some decisions to be made there with regards to the CapEx and OpEx trade-offs. And then just to sort of tie it off, I think I've maybe alluded it to already, but just in terms of looking at steps towards commercially viable projects, if I had to say one word, it would be collaboration, and that would be collaboration across the value chain, meaning from the biomass side right to the transport and storage side. Also looking at how complex it is, how many steps do you have along the way, and how does that translate in terms of actual CO2 that is captured and stored, and the costs associated with that. The next thing is to basically realize that you're lifting multiple value chains at the same time. So with ourselves, and then also with partners, we are all looking towards that 2030 horizon. And if you work backwards, RFIDs are all around the same time. And it really requires collaboration and trust to kind of bring that together so that we can all realize these projects in time. And just to mention, although not a focus of my talk today, just to mention that obviously we also need regulatory support at both national and EU levels. So it's been encouraging to see a few steps in the last couple of months with regards to the London Protocol and others. But yeah, the regulatory support is also quite important. And then just to finish off, because it's all something that we haven't really done before, it doesn't exist at the scale that we want. There's no hand for us. Having a creative mindset, I think, is also very important, that we trying to solve a puzzle that hasn't been solved yet. So that would be my final point. So thank you, and have some questions.